So I will do a brief introduction, and I pass to Khalil to start the session 4. So today, the outline is we will do two hands-on. The first one will take approximately 2 hours. We'll start by doing how can I say? We started by creating advanced AI workflows and performing hyperparameter optimization with MLOS. And so we started first by creating a deep learning workflow from scratch. And next, we will optimize it, configure it to be optimized by MLOS. And the next, we'll show how to perform data visualization on Tensorboard. And the next, we'll do a quick pause, and we'll pass to Khalil to continue the hands-on, but creation and an advanced AI workflow with using the Python SDK and the Jupyter Kernel. So Khalil will show you how to deploy a Jupyter Lab service, and next how to create and submit AI workflows using the Python SDK, as well as the Jupyter Kernel. The first step for the first hands-on, we'll start by creating a proactive catalog. Caroline will show you how to do it step by step. Why? Because the proactive catalog will be used to store the workflows you will create during this hands-on. So the idea is to each participant of this hands-on is to create a catalog, for example, named your first name underscore workflows. So Caroline will show you how to do it step by step, and the next she starts the hands-on itself. So this catalog is very important to make sure your workflows will work with the AutoML mechanism. So let's start by doing this.
Okay, I will present myself again. My name is Caroline. I did my PhD in machine learning. My main focus is in computer vision and feature extraction. Currently, I am a computer vision engineer at Activeeon. So today, we will develop together some amazing AI example using MLOS platform. So let's start by creating your own proactive catalog. First, open the dashboard interface. Then click on catalog menu. You can see here the every step. For example, for the catalog menu, you can see the step number 2. Like Andrew said, we were able to save the workflow in this catalog. Next. Now click on Add button, this button here. Put on the bucket name field your catalog name. For example, you can use anything, but you can, for example, you can use your first name underscore the workflows, for example. And then click and add bucket.
Okay, try to replace the underscore by minus.
Now, we create a deep learning workflows for Scratch using your own code, for example. Now go to Proactive Studio homepage. Create a new workflow, use the create button, like the step 2, and then click on imitate the workflow 1, like step 3. Then click on basic examples menu. Here, step 4. Finally, drag and drop the Keras task in workflows template. Here in the session 4, you have some template for facilitate the work. Okay. Now you go to the GitHub repository. You copy all code. I will send you the link for GitHub. Access GitHub. Here the link is done. This code trains a sample convenient network using MLOS dataset. Now go back your Studio interface, click in Task Implementation button in the step 8, and in this small button called Edit button, step 9. Then paste all code in the, put your code here in this section. You need to find the put your code here section, like here. You put your code. And finally, save and closing this interface. Okay. Now we will publish this code in the catalog. First, click in the catalog menu here, step 12. Then click in publish current workflow button. Yes. Now click in your one catalog name, and then click in publish to save your workflow. You can see your catalog if you click in this button, add button here. You can click here, then you can see see your catalog. Avec your workflow. Now you execute these workflows. This workflow, for example, you can, when first you click here in this button, execute. Then make sure you select the Islam GPU node. In the final, you click in execute button to execute your workflow. To see the job execution, you click in schedule and orchestration button.
It seems that I check the system output. Okay, nice. Yes, the AI workflows, the Keras tasks are running well. So the Renault job is okay. The job for the very user, let's check. Yes, it's okay also. The job from PainRunet, let's check. Okay. Yes, it's okay also. Yes, I think the platform is back again. The GPU workflows are running well. So I let Caroline to continue the training.
Okay, great. To see the results, you click in your job, and then in the job results button, you can see everything about your job. Okay. We can see the download of the MINST, that data set.
Yes, I think this is a question for Fabian. Fabian, for Chibot put a question there is on chat asking for the streaming output. It's possible to stay at the end of output without scrolling.
Hello, Thibaut. Unfortunately, no. That's a good remark, but it's not currently possible. You need to scroll.
You can see the results in the end of the task. Accuracy and loss. Okay, I think it's all for my time. Now, Andres will show you how we optimize this code using our AutoML.
Okay, thank you, Caroline. Now, the next step is I'll show you how to do a similar step like Caroline did with you, but we'll configure your code to be able to be optimized by our AutoML workflow. So let's start by creating a new workflow. So we'll do a similar step as before, but with a different configuration. So let's create a new workflow in the studio. And now you will click on the deep learning preset in the top of the studio. So for me, it's already selected, but you should click here in the top on the select deep learning. You should be able to see a screen like same of mine. And now you will click in the AutoML optimization catalog and select a template Python task in the template section. So let's do it interactively. So you should click in the AutoML optimization and drag and drop the Python task template. Now, let's go back to the presentation. You will go to the same GitHub repository like before, and copy and paste the code in this task. So let's do it together. So you come to the GitHub repository, you click in the code, you can select this whole code until the line 18. So you copy this code and go back to the studio and click on the Python task. And next, you should click, sorry, in the task implementation. And clicking to the task implementation, you should click into the edit script button like this. And you should copy and paste your code in this section here. So let's do it. Okay. So after the copy and paste, let's go back to the presentation. The next step is, okay, this one we already did. Save, put your code in the section. Click on save and close. So save and close. Next, I think this is not yet okay. In fact, this slide is wrong. Save is on the close is in the end. Yes. So we should click here to edit again the task implementation. And now let's bypass the slide 27 and go to 28. So the 28, you should replace the line optimizer equals Adam to variables batch 128. So it's the line 8 here. So you click into this line, you select optimize equals Adam, and you copy and paste the batch size equals 128. This is the default variable value for the batch size. As you can see in the code you copy and paste, there is already a predefined batch size here. So let's comment or remove as you want. So you comment this the batch size variable here in the code itself, and in the top, in the default parameter section, we put it here. Okay. Now, for the slide 29, so the step 14, in the input from AutoML, you should replace optimize by batch size. So in the input from AutoML section, this one, you should replace this one by this one. Or you can replace or you can comment as you want. So the idea is to replace optimize equals input variables to batch size equals input variables batch size. And we comment this line, or we can replace selected optimize by selected batch size. Okay.
And just a remark. In fact, you can optimize any parameter you want. Batch size is just an example.
Yes. In fact, the idea behind this manipulation is to illustrate how you can optimize a single parameter, but you can optimize many you want. You can optimize the algorithm beyond several parameters like batch size and the number of epochs and other parameters you think it should be optimized. So the idea is to illustrate how you can do it with one single parameters. Sorry, one single parameter, and this is the same if you want to add more later. So now let's go back to the presentation. And for the step 13, in the output from AutoML section, you will copy and paste this code in the right side. So we should only rename. So let's show you at the end of the script. You find the AutoML output for AutoML, and here by default it's 0. And now you should only copy and paste the score 0 instead of 0 itself, and score 1 for the accuracy in the ACC variable. So yes, that's all. So the loss variable is the variable that the AutoML workflow will try to optimize, and the ACC is the accuracy that we can see it during the training of the model. And that's all, I think. Let's go back to the presentation. Now we can save and close. So let's save and close this script. And Now we'll configure the workflow variables for this task. So let's go to the workflow variables. You should click outside the task, because if you click onto the task, you can't see the workflow variables. You just see the general parameters with the task variables. So you should click outside the task, and you can see the workflow variables. And here, let's go back to presentation. We should perform some small modifications. So for the next slide, we'll copy and paste this search space definition. So the search space definition, we have some keywords in this kind of JSON string format. So choice, it means the AutoML will try to select one of these byte size in each iteration. It also depends of the optimization algorithm selected, but usually it will try to make a search in this list. So let's go copy this code and put it into the search space variable of the workflow. So let's do it. So search space is the before the input variables at the end. And now, instead of optimizer, choice, Adam, SGD, and RMS prop, we copy and paste this one. Batch size, choice, 32, 64, 128, and 512. So let's click on OK. And now, so let's go back to the presentation. And now in the next slide, we do the same for the input variables. So we should copy this code, go back to the studio, go back to the workflow variables, and in the input variables at the end, we copy and paste this value. And we should publish this workflow into your own catalog, like first name minus workflow. So let's do it. I will create my own catalog also. So catalog plus Andres workflows. Okay. And now, sorry. And now I publish my workflow here. So let's do it. Catalog. In the studio, you should click into the catalog, publish current workflow to the catalog, and select your own bucket. And now you can publish it as a new workflow. By default, named Python task. Publish, yes, okay. And coming back to the presentation. So this we already did. And now to make sure that this script, this Python script, this workflow is okay, before launch it with AutoML, let's click into the play button here, execute, and select is learn and a GPU node, the PGL318_GPU. So let's select a GPU node from Slurm, and we don't touch into the rest of the parameters. So let it as is. We should, this is only to check if there is nothing wrong into our configuration. So let's execute it. And now we click to the scheduling orchestration button. And you see my workflow here. It's awaiting a GPU node from Slurm. Now it's running. So I think, yes, it seems to be okay. So it's using the GPU, CUDA is enabled. The selected batch size is okay, 128, but because this is the default value we put into the workflow task. And now we can see the whole execution. So let's wait a few seconds. Everything is okay with your workflow, though there is someone having some issues, or maybe I am fast or slowly, I don't know. So for my workflow, each is in the epoch 5. Now it's epoch 6. And if you go to the resource manager, okay, we have 2 GPU nodes here, one for me, one for PayRootNet. So now we check that the workflow is running well. Okay, the step we already did. We already did this one. So check the visualization, the task progress. Now we'll go to the AutoML part. So let's go back to the studio. And now you will create a new workflow. So let's click into the create workflow button. So we select a new empty workflow. And now you should click into the AutoML and drag and drop the multi-tunnels AutoML workflow we saw yesterday in the afternoon. So this workflow will be responsible to launch and optimize your previous Python task. So coming to the presentation. So select the workflow, drag and drop to the studio. Now we should click into workflow variables. And in the workflow to optimize the variable, you should put the URL of the bucket name and the name of your our workflow. So for my case, it's Andrew's workflows / Python task. So let's do it. Okay. So you should do the same for your own catalog name and your workflow name. By default, it's Python task, but if you someone was renamed, you should put the final name here. This should be the same name you published in the catalog. If I go back to the catalog, you can see Andrew's workflows, my Python task here, and the same for the other participants. Okay, so let's click into OK button, and the next thing is the max iterations. So the max iterations, let's go to the studio. The max iterations by default is 2, but you can set it as you want. You can put 10 or 11 or 18 or 100 or 1000. So you can put how many number of iterations you want. It's the number of loops that the algorithm will do. As this is a sample workflow with a small list of parameters choice for the batch size, so we don't need to make several iterations. It depends of how is complex your search space definition. So for this small example, 2 iterations is okay, because if you put, for example, 50, sorry, it will loop into the same hyperparameters. So because we have only 4 choice and many a number of iterations much more higher than the search space definition. So it depends. The number of max iterations, it depends of the complexity of the search space. So let's put it with 2, and the same for the parallel samples per loop. So this is the number of how many parallel workflows you want to optimize at the same time. So for as this is a sample sample task with a sample search space, so 2 parallel samples per loop is okay. Or if you want, you can put 1 max iteration. So coming back to the AutoML workflow, as you see, you have 2. I suggest you 2 options. Or you put the max iterations 1 and the parallel samples per loop 4, or you can put 2, 2, or 4, 1, as you want. This is the same. The only difference is that if you put only 1 max iterations and the 4 parallel samples per loop, you should see 4 executions in parallel of your workflow. And if you inverse this number, if you put max iteration equals 4 and parallel samples per loop equals 1, you should see only 1 execution of your workflow per instance per time. So you should wait 4 loops of your workflow optimization. So is much is lower than making 4 parallel at the same time. But it is important to see that it depends also of your infrastructure GPU capacity, because if you have only one GPU available, so there is no difference, significant difference between switching the max number of iterations and the parallel samples per loop, because you have only one GPU, so it's don't change the final behavior. Sorry. So for my case, I let choo, but I let you to enjoy to select the numbers you want. And coming back to the presentation. So the same for parallel samples per loop as I explained it before. Okay, now we should, you can select the tuning algorithm before the execution itself, or you can select the tuning during the execution, as you want. You should take attention because some algorithms can be are discrete, others are mixed, and others are continuous. So if you have an error, it's because maybe it's because you have selected the wrong algorithm. So I can suggest you, for example, the bias, the CMAES, and the random, or even the grid, because they can be used in this example. So for my case, I click here in the tuning algorithm. I put random because it's the most used. It's very simple, but you can select bias if you want. You can select CMAS if you want, or even grid. So I let you to enjoy some of those options. Let's click to OK. And now I'll click to execute. And for the execution, as you see in my screen, so the random was selected by default. 2 max of iterations, same for the parallel samples per loop. The workflow optimize is OK. Andrews minus workflows / Python _ task. Okay, make sure this is correct. Same for the algorithm, and same for the number of iterations and the parallel samples per loop. For the other parameters, you can let it as is. And for the first one, make sure you have selected Slurm and GPU to optimize your workflow in the GPU. Okay, so let's execute it. And now let's go to the scheduling. You can see my job is here. It's waiting some Slurm GPU nodes. You can see the progress in the visualization tab. So let's check the job variables. So in my case, job variables, you can see is learn, NS batch GPU node, my workflow, algorithm, max iterations, parallel samples per loop. Let's check this one. So same, okay, true. This workflow is learn, though it seems to be okay. Let's check the output. Now it is submitting two instances of my workflow. If you see now in the scheduling portal, you can see two Python tasks from Andrews. So if I click into the job variables and you switch between the two jobs, you can see that the first one, the batch size is 64, and for the next one, 32. So each job will run a neural network model training with the selected batch size. So if I click into the output of my first job, you can see selected batch size 32 and the same for this one. Selected batch size 64. So let's check the other job. Parallel samples per loop 3, max iteration 4, quasi-random is learn. Let's see this one. Okay, this one with batch size 511 and 64. In my case, let's check the progress. So it's waiting the finish of the training. So it's in the epoch number 3 for the first task. The next one is in the epoch number 5. Okay, now we have 3 Python tasks from Shin that are being optimized. Okay, I think Jin forgot to publish into the catalog the modified version of his workflows. This is because there is an error in the in his Python task. So it's very important for any user to make sure the modifications you did in your code to be published in the catalog before running the AutoML, because the AutoML use the stored workflows in the catalog to optimize. So this is the cause the AutoML from Shin was crashed. For the others one, let's check the progress. So now one of them are in the epoch 4. This one I think is more advanced. This is into the epoch 7. Let's check this one. Usually you can't see the output from the other's user job. I can see because I have an admin account, but usually you don't see the logs from the other's user. Now we have a lot of workflows running. Okay, the same for this one. It crashed because there is a misconfiguration in the script. If you want, you can launch anytime you want a new AutoML workflow. You don't need to wait to the AutoML to finish before submitting anyone. You can submit just after you did a new modification. Just make sure to publish into the catalog before. So now let's check. It's the same. The Python task is not up to date. For this job, there is the node source, the NAS that was not selected. So if you don't put isLearn and the GPU, it will use the CPU nodes from the controller. From my side, let's check it again. So it's waiting this job to finish. Okay, it's in the last epoch. Okay, it's done. So now I have two optimized workflows. I will have a new ones because I have put two iterations with two parallel samples per loop. So the workflow will trigger a new Python task two times. Yeah. Now I will show you how to see those results into the job analytics. So let's go to the automation dashboard and let's go to the job analytics and click here. For the search, let's select Python task. My one, because as you can see in the workflows name, there is a Python task from different users. So let's select the mine. So Python task, this one, and today. Okay. Now you can see the first test we did before AutoML and the next two executions in the first loop of the AutoML. And as well, we can see the two running Python tasks from the AutoML. So it's two running. You can see also the batch size of each one. It started with 32, 64. Now it's running two Python tasks with 128 and 511 into the batch size. So you can track your experiments easily using the job analytics. So you can see the input variables here. So if you click into the legend, it shows the job ID and the selected batch size. And the first widget, you can see the job duration for each job ID. As you can see, for this 162, this one, the first one, job ID 6225, it's the longest one, 9 minutes to finish. Instead that this one is quite fast. And the same for the results. So if I enlarge this one, enlarge the variables, now let's enlarge the results. So the result, if you click into the legend, you can see the accuracy and the loss, or you can click and select the one you want to see. So as you can see, there is a minimal loss difference between the three previous executions. So this one is 0.02, this one is 0.03, This one say similar 0.03. And if I switch from accuracy to loss, same. So 99% of accuracy, same for this one, and same for this one. So usually it has a good accuracy. There is a very, very minimal difference of accuracy if you select the batch size. And you also can see the results in the table at the end, in this table. So you can order by the loss, the better one to the not better ones. So you can see the accuracy also. You can drag and drop the column and put it together. And same for the accuracy. Let's get it and put just close. Okay. So this one, it was the first execution we did manually, and those ones, the previous execution for AutoML. If I refresh, let's see if we have a finished workflow. Yes, there is only one that is running, and same. So this one is a little bit better than the previous two ones. This last one is still in execution. So let's go to the scheduling. Okay, so my 4 executions, okay, so I can refresh again. Okay, now it's well done. So now we have all results. So the best one is still the first execution for the loss. And the accuracy is, don't change a lot between those executions. Any question at this stage? Let's check the chat. Can we rescale the axis of the graph? Miriam is asking. Rescale, I don't think so. you can switch between the variable selection. For example, in my screen, if I let loss and accuracy together, yes, there is a big difference into the scale of the variable. But if you click into hide and show legend in the top right, you can hide the accuracy and let only the loss. And the same if you want to switch between them. So let activate accuracy and let hide the loss. So you see only the accuracy. So you can select which variable you want to visualize, but yes, there is no mixed view of both variables at different scale. For instance, there is no option to change, to rescale the axis. The better is to ride the variables you don't want to see to better see the selected one. But for the next step, I will show you how you can have a similar visualization by using Visdom and the Tensorboard. So you can enjoy by using some features provided by those platforms. So just to give me a second. So let's go back. Any question, for instance? Okay. So I close the job analytics. Let's close this one also, this one. Let's check the services. Let's see, there is some service that's not okay. So let's pause, finish this one. Just to clean up. Okay. So now let's suppose you want to have Visdom or Tensorboard as visualization. So let's go back to the presentation. So this one we already did, this one too. Okay, job analytics. Okay, so now we start by showing you how to add support to data visualization with Tensorboard and Visdom. So let's start with Visdom first. So let's go to the workflow, this one. Let's execute it again. Always select Slurm, GPU. And now, if you want to plot the same visualization you have seen into the job analytics using Visdom, you can click into the Visdom enabled here. You switch from false to true value. So you just need to click here. Visdom enabled equals true, and that is all. Yes, for the instance name, to make sure we don't have any conflict between the execution of others, I will put my name at the end, my first name at the end of the Visdom instance name. So instead of Visdom server only, you put Visdom minus server minus your first name. Okay. And now, to be more fast, I will decrease the max of iterations, and I will put 4 parallel samples at the same time, just to be a little bit faster. So you can see the visualizations in less time. So let's execute. Click on scheduling. Now it's starting. Let's see the job variables. Okay. Let's see the resource manager. Okay, I can see a GPU node to be reserved for my execution. Oops, there is a small thing I forgot. Visdom endpoint. What's happening? I'm just checking. Maybe I forgot to continuation 1. Okay. Yes, I think I know the problem. Visdom server. Let's check the service. MongoDB, Visdom.
It's a problem about the endpoint.
Yes, I think we had some delay. Let's check. Yes, I will restart the AutoML again. I think there is a small issue with Visdom. It's not the AutoML can't see the endpoint of Visdom. There is a small connection issue. So let's finish. I think my workflow is already finished. No, not yet. Okay. So I kill this one. Kill this one. Okay. So finish MongoDB. I do the same for this one. So let's start again. Okay. So let's execute the AutoML workflow again. Slam, GPU, random. For the Visdom instance name, let it as is, just for testing. And for the Visdom enabled, let's put it on true. True. For this one, I put 4 and the max iteration 1. Random, Python task, Visdom enabled. And Visdom instance name, we don't change, let it as is. Now let's execute. Yes, now it's working. So I invite you to resubmit the AutoML again. And if I come to the automation dashboard, I can see the Visdom service here. And if you click into the endpoint of Visdom, you can see the Visdom interface. Okay, and now for this AutoML experiment, you can see a text box here. A new experiment was created. Please see job ID 6276 for more info. So if you want to visualize the progress of your job, you just need to click into the Visdom environment, select the correct job ID, uncheck the main, okay? And now you can see we have two widgets that have been initialized, but they are waiting for the execution of the workflow. So when we have the Python task finished, you see the plot here. So let's go back here. So you can see 4 Python task execution. The first one is with batch size 511. This one with 128. This one with 32. And this one with 64. Okay. Same if you see the job variables. You can see the batch size value here. Visdom endpoint, the input variable, the slash space. So the only difference between them is the batch size value. Now we should wait for each execution. Let's check this one. Not found. For the workflow, AutoML workflow from Jaswal, it says the Python task does not exist. So Navin underline workflows. Ah, yes, the problem is here. You should put, let's check into the catalog. Yes, it's minus instead of underline. So you should fix underrun again the AutoML. So you should put the correct bucket name here. So the best is to kill. You can kill this AutoML job and resubmit again using the correct bucket name. Let's check the chat. Okay, thank you, Chu. Any question, for instance?
Andrews, maybe you can show that you can resubmit it directly from the previous job. So if you click on the job and you do right button, there will be a contextual menu where you can actually resubmit the job, just changing some of the parameter.
Yes, The different way to submit the AutoML job is by going into the AutoML workflow automation and select the bucket AutoML optimization. And now, sorry, you can see the same bucket in the studio, and you can click in the AutoML and you can configure it to be launched here instead of the studio. So if you already have a workflow that is already published in the catalog, you just need to put the correct URL, the correct path to the workflow here. So make sure this path is correct, and this is all. So, yeah.
We have a question.
Let's see.
Andrew, before you see the question, I wanted you to show that from the scheduler portal where you were just before, you can click on the AutoML job again. Yes, and you do a right button, right click, and here you have a resubmit. So if you have entered some specific parameters on the previous time and you don't want to retype them, if you resubmit here, you will have the former parameters that will appear. You see the resubmit, Andrews?
Yes. So let's, for example, resubmit the job from Jaiswal. So resubmit, and now how can I take Visdom enabled? Learn. So instead of navin underscore workflows, you put navin minus workflows. And for the NES batch, let's put GPU. Okay. And max iterations 1 and the parallel samples per loop 4. I think for the orders parameters seems to be fine. Let's check it again. Okay, it seems to be fine. So let's resubmit it again. The only difference is that it will be submitted by using my username instead of Jaiswal name. I have a question from Miriam that is saying that she don't have access to any link Visdom guy to the cloud automation. Let's check it.
Yes. Not heavy.
So
I think it's maybe the same name about your Visdom.
Visdom. Click here. Yes, for me it's working. Miriam, can you check if the IP address is the same of mine, please?
Maybe Andrew, you can cut and paste the IP address in the chat.
Yes. So let's put it into this chat. So everyone that is connected into the VPN can see the Visdom dashboard.
It's the same address.
Yes. So for my case, as you can see, we have already 2 results. So the first one with 0.03 for the loss function, and the next one 0.02. Let's check the scheduler. We have some experiments that are still running. I have put into the chat the link. No, in fact, answering the question from Miriam, no, in fact, you only should click into the link, your IP address I have put into the chat. This is not the IP address from you, this is the IP address from the Visdom server that has been started in our cloud automation portal. So make sure that you have selected the correct job ID in the Visdom environment. So if you see my screen, usually when you go to the Visdom the first time, you will see this screen by default with 3 small text widgets saying that 3 new experiments have been created. If you want to see the plots of each experiment, you should click into Visdom environment and select the job you want, but make sure to uncheck the main before. So let's uncheck the main environment. Okay, so we have nothing in the Visdom portal, and now click into the Visdom job you want. So now you can see we have a small plot here. If I switch to the next job, same. I have 4 results here. And for the next one, we have nothing because the experiment is running. So if you want to compare, for example, this job ID with this one, you can check both, and Visdom will make a merge in the plot. So if you drag and drop here, you can see in the x-axis the job ID, and in the y-axis the loss for each job ID. So this one was the first 2 job IDs, and these 4 later ones are the job IDs for the next experiment. So this helps you to compare 2 job executions. Why Visdom is offline? Maybe someone closed the Visdom. Let's check the cloud automation. Okay, it's back. Okay, the Visdom is back. Okay, so now we have 4 results for this one, and 4 results for the next one. Let's check this one, nothing yet. Okay, good. So now you can see the 2 AutoML executions in the same plot. Now let's do a quick experiment, but using TensorFlow, and that's all. We can finish this session. To use the AutoML with Tensorboard is very easy. You can resubmit, just resubmit your job, or using the studio here, or by clicking into your job and clicking to resubmit, like this one, resubmit, but let's do it by the studio. You can see the whole parameters at once. So I will resubmit my job now using always Slurm and GPU. For max iteration, let's make it 1. Parallel samples per loop is same, 4. And instead of checking the Visdom enabled, let's check Tensorboard enabled instead. And for the instance name, let it as is. And the Tensorboard log path, you can let it as is. So just make sure to click into the Tensorboard enabled. The max iterations parallel samples per loop, I let you choose the as you want, the value you want. And just make sure the workflow to optimize is correct. And you have selected the Slurm and GPU. In my case, I use selected the random algorithm. So let's execute it again. So let's see the progress. The Tensorboard was initialized. Okay. Let's see my workflow. Tensorboard is this one. Tensorboard enabled true. Let's check this one. Okay. And now let's go to the cloud automation and click into the Tensorboard GUI endpoint. I will copy and paste this endpoint into the Zoom chat. For instance, we don't have any result because the experiment not started yet. So if you go to the Zoom group chat, you can see the IP address of the Tensorboard web portal. Now we just need to wait for some experiments. We have nothing yet. Usually the Tensorboard will refresh automatically in 13 seconds, 30 seconds at time, yeah. So let's go back to the Tensorboard or to this scheduler. We have 4 Python tasks in execution. Okay, so let's check the parameters. Good, good, good. Let's wait a few seconds. We have 4 GPUs, okay. If you want to, there is a second way, but that is more advanced, that you can do is to plot. You can perform some personal plot using the same Tensorboard instance. So if you go to AutoML optimization, if you click into the CFAR10, for example, this one, and you go to the task implementation, you can see that this code use the keras. Let's check model evaluate this one. Use this code, use the callback to the Tensorboard. So the advantage is that you can not only track your global experiments using the Tensorboard, but you can also use the Tensorboard instance to make your own plots if you want. If I show you another example, let's clean up and drag and drop the MLOS function. If you click into the task implementation, you can see this is a mathematical function that you want to optimize using the generated values from the AutoML for the variables x and y. You send back to the AutoML the loss from this function, and if the Tensorboard is enabled, you can manually do some plots by using the Tensorboard functions, internal functions, like add text, add scalar, and others one. Same for Visdom. If you see just after, we have a small block of code that use the Visdom instance and do some personal plots, specific plots using the Visdom functions like scatter and plot line, text. So you can, if you want to make some experiments, you can use this template as a base template for your coding, your AI workflow. So let's check if you have already experiments. So I will refresh Tensorboard. Not yet, okay. So we should wait to finish. Have how many? 2, okay. We should wait those 2 ones to be finished. This one, let's check. Let's see the chart. How to get the screen of multi-tuners AutoML. I'm not sure I have understood the question from Navin. So just hide my zone controls. Let's drag and drop the multi-tuners AutoML. I don't know, Navin is talking about this interface, this screen, or a different one? You are talking about this one? Okay. So for this one, yes, you can resubmit your AutoML workflow. Just make sure you have filled the correct fields with the correct values. So usually we put in the NS Islam, as you can see in the definition from the right side. So you should put Islam, for example, here. If you want to have Visdom or not, you can put Boolean value here. For instance name, it's okay, you don't need to change. Node source name, you don't need to change. Visdom enabled, you can change if you want. Here, I suggest you to put Slang, but it's not mandatory. Visdom password and the node access token, you can let it as is. Workflow to optimize, you should put the correct path here. And for the Visdom username, not need. Visdom enable login, not need. Parallel samples per loop, you can put an integer value you want. For the Tensorboard log path, not necessary to change, you can let it as is. Visdom proxify the same, this one the same. Tuning algorithm, you can choose one of those, like random, grid, bias. For the Docker enabled, usually we let it as is. Max iterations you can enjoy by switching from an integer number you want. And for the NS batch, if you want to use the GPU node, you should put -p GL 318 underscore GPU, this value here. And the same for the Visdom server instance, so not need to change. And the Tensorboard, if you want to enable it, you should put true, the true value here. And the next, you click and check. So the job is valid, and you can resubmit it again. Thank you.
Now you can see the Tensorboard results.
Okay, so let's go back to the Tensorboard. Nice. Now we have some plots here. And if you want to have full views, click into the smooth, decrease it. Okay, and let maximize. Okay, by doing this. Good. Now you can see the same plot, similar plot, because this is a new experiment. You can see a similar plot as you have seen in the job analytics and Visdom, but using Tensorboard instead. If you want to add some personal plots, you should make some code, internal code modifications if you want. You can reuse the same Tensorboard instance and perform some plots, specific plots. But for generic plots, it's automatically done by the AutoML workflow. So for the text, same. We have some text plots here. and some scalar plot here.
In this part, as said by Andrews, we will try to learn the basics to create a workflow without accessing the studio, or minimizing the access to the studio for people that wants to use their own IDE or the Jupyter Lab platform. So as a start, I will try to go quickly in this part since we did it yesterday. So can you all access the automation dashboard? Click on Cloud Automation, and then look for the Jupyter Lab PCA service, like here. You go to the automation dashboard, Cloud Automation. For people that finished with these PCAs, please, if you can finish them, it will be great. So we look for the Jupyter Lab. After, to run it, as said yesterday, so the name, the instance name, and the endpoint ID should be unique for each user. So please add your minus first name in both instance name and endpoint ID, as I will do here. Great. So keep HTTPS to false. As we saw yesterday, we have a little bug with the Jupyter Lab token, but it will get fixed easily. So if you want to use the token, feel free to do it. So I will launch the Jupyter Lab instance. So this is it. Now, just you click on your own endpoint icon here to open your Jupyter Lab instance. So I will disable my dark mode. Okay. So please let me know if you have any issue with it. As I see just Miriam, maybe that launched her instance.
Miriam said that it works.
It works well. Yeah, thank you, Miriam. I don't know for the others.
Instance name should be any name, right? First name and the Jupyter or something.
Yeah,
you mentioned.
It's as you like. It's just that the instance name and the endpoint ID has to be unique. So you can add whatever you want, but not a common 1, 2, 3 or something else.
So both instance name and endpoint both can be same, or is both has to be unique for both cases?
No, it can be the same. It's not.
Okay.
It's not very important. Why the instance name has to be unique? Because it will be the container, the Docker container name. So we are not able to run two containers with the same name. And the endpoint, we have a mechanism that allow people to have two PCAs, services that point to the same endpoint. So if we will use the same endpoint, this information will be overwritten in the database.
And there's no need of Jupyter token?
It's optional. It's as you like.
Okay.
Oh, I see Jinshin, the instance. Nice. Okay, so by clicking after on the endpoint endpoint icon, you will open your PCA plan, your Jupyter Lab platform. So is it okay for everyone? Nice. I see the instance of Navin.
Thank you.
Sure. So let's move forward. So since you are here as a start for the Python SDK, you will open the double click on the folder Proactive Jupyter Notebooks. You will get these notebooks. You will start by opening the Getting Started PA Python client notebook. So as I will do here, you open this folder. After you open the Getting Started PA Python client, and you will get this first notebook that we will start with. Okay, so to test it, you just have to change the host. So we will use the host that we are on. Like this. You start by executing, I will restart the kernel. You start by executing the import, this block that will create the gateway created. Here you will put your login. And for the password, you can use, you can put, you can code hardly your password, or you can use this line here. So getPass.getPass. Sorry, I forgot to import getPass. I'll execute again. So here you put getPass.getPass, parentheses, prompt equal password. And when you will execute it, it will ask you for your password. Okay, here we are connected. After, you will continue by executing the other blocks. You don't have to change anything. So I will explain a little bit. Here I create a task, a dummy task with the gateway.create Python task. I set the name of the task and I set the implementation. I set the implementation here. And after, here I create the job with the gateway.create job. I set the name of the job, and after, here I will add the task to the job. I just proactive job add task. And here I will submit it to the scheduler. So as you see here, we can go to the scheduler and see that your workflow is running. No. Yes, it's this one for me, for my side. And you can get the results and print it here. So hello from my simple Python job world. We can do connect afterward. So is it okay for everyone? Nice, Miriam job.
Why I see installed actually my Jupyter one?
This one? Okay, so
Yeah.
let me explain it otherwise. I will show you the workflow, the base workflow of the PCI service to understand. So it's here. So as you can see, the PCI service is basically a workflow that is composed from a task, which is start the PCI service, and a loop. So since the PCI service is when it is running, it's still executing in our database, in the scheduler. So we have this loop, which is an infinite loop that will be stopped just when we will execute the finish action from here. So when it is executing, well, what you see in the scheduler is just this loop executing and iterating. You see? So here we have the start Jupyter lab that has been executed and finished properly, and after we are in the loop phase. I can even go forward and show you that when you run a PCI service, you have this little dot on some nodes of the server. That means that this node is reserved for an instance of the Jupyter of PCA. So for example, here, if I do edit tokens, you can see that I have reserved this node for my PCA by adding a token mechanism, and the name of the token is Jupyter Lab Server Khalil, for example. Is it clear, Alan?
Yes, it is. Thank you.
Okay, nice. You're welcome. So let's move forward. Here it's okay, I think, for everyone. We will do the first exercise. So the first exercise, just open the folder training exercises here, and we will start with the PID exercise. So just keep the Getting Started PA Python client notebook open. You will start by duplicating the PID exercise notebook to work on the second one. You open your duplicated notebook. You can close this part by clicking on the folder icon. After, you will drop your Getting Started Python client notebook on the right, and I will ask you to try to get inspired by this notebook to transform this sequential notebook to a proactive workflow. So as you see here, this is a very simple notebook that imports a library, initialize two variables A and B, and after and print the PID of the process that is executing this script. And after, for the second part, we do the same. We print the PID, and after we do some calculation on with the variables A, B, and we print the sum. So for sure, to do it, I drive an outline here. So you will start by you make sure that you add a new block for each step to not modify this script and iterate it. You will start by importing the three libraries, OS, GetPass, and Proactive. You create the gateway and you go through this outline as it is done here. So is it okay for everyone? Is it clear?
Previously also explained the same thing, right? Is that correct understanding that we need to change the gateway earlier also? Or is it this lab has a specific requirement?
I don't think I understood well your
No,
question.
the previously when you explained to set it up, and we were trying, and I just wanted to understand whether this is a specific task which we have to do, or is it before the earlier when you explained in slide 70 and above is the same thing we have to execute, or is it a hands-on from this perspective?
Yeah, actually, this
what I mean to say, the gateway one, I am a bit confused. Is that a gateway? How how is it correlated here?
Okay, so the gateway mainly it's a way to facilitate the use of the Python SDK. So it's a way to connect to the Java platform, the Java runtime of the Proactive server. So each time you will connect by using the Python SDK, you have to create the gateway. It's not just related to this training. So I don't know if
got it. Got it. No, I got it. I got your point. I was just thinking is related to this one that we have to be mindful.
Actually, it's not related, and you will have to use a gateway each time. As you can see here, we use the gateway to connect. We use the gateway to create tasks even and create the job mainly. So through the gateway, you will just connect to the Java runtime of the Proactive server, and it will allows you to create the Java objects behind to create the workflow.
Understood. Thank you. Appreciate it.
You're welcome. So, so I don't know if it's clear for everyone, the exercise. I will let you do it for 5 minutes if you want, and after I will do it with you. So I don't see workflows executed, so maybe we have to do it together for this time. So like I said here, we started by importing the 3 libraries. So we will get inspired by this one. We start by adding this part. Okay. After, we will create the gateway in the same way as the Getting Started notebook with the same host and port. After, we will connect using our credentials. Nice. After, when creating the first task, I said here, create the init task using the initialization block script. So we will copy the creation of the task. We will name it init, and we will put this script here. As you saw. And since we are creating a workflow of separated tasks that can be executed in parallel, we have to add the imports for each task separately. So I added the import OS here. I execute. Good. Now, after we create the calculation tasks and add the dependency between task 1 and 2. So, sorry, I will do the same, call it calculation, put the script of the second task here, and add the import OS the same way. After that, we create the job. So make sure you added the import to both task scripts, as I did. Make sure you propagate properly the variables A, B from task 1 and task 2. Yeah, okay. So in this scenario, as I said, the tasks are separate, and maybe we have the dependency, but we have to propagate variables A and B from this task to the other one. So as explained by Fabien and Mohamed yesterday, we have to do to add variables dot put, we do the a as the variable name and put a like this, and do the same for the b variable. And in the other side, we will do the same, but we will do a dot variables dot get, and same for the b, like this. So now we propagated the variables from one task to another.
How do I write a title on top of it, like 8 or above in the blocks? Like you have written initialization. If I write something, how do I write here?
This one, the name of the task?
No. Above, like initialization in block you have written, right? Like imports. How do you do that one?
Okay, so to do this, you will add a block just before. You will change the here from code to markdown. And if you see, if I write anything, it will be took as a markdown. So to write a title, you will do like this, and you can say creating a gateway. And when you execute it, it will come as a title.
Understood. Thank you.
You're welcome. So we are good for the variables propagation. Is it clear for everyone, I guess? Okay. After propagating the variables, we will create a new job and name it. So we will create a workflow like this. We will name it, you can name it as you want. Speed exercise, for example. Nice. After that, we add the task to the, sorry, I forgot something. Like we created both tasks with the same name, we overwrite the task. So you have to change, for example, here, I will do it. It's ugly, but it will work. Here, I will add task like this and add task one. That's good. And after, we can submit the workflow to the scheduler. Oh. Oh, I did not change the name of tasks. That's weird. I will restart. This, this, this. 20. Here the name is init. The name is calculation. Nice, I create a job. I added the tasks and submit it. And now it works. If we go to the scheduler, this is one. What did not work? What did I do? To
Khalil?
we received none. Yeah, tell me.
Messages.
Maybe I have a problem here in the syntax error.
Timbo said, I think you used the Groovy syntax for the variable propagation.
I will check. Just 1 minute. Takes time. I did not use this syntax in Python for a long time, so this is why maybe I forgot to do something. I'm checking the documentation.
Khalil?
Yes.
You receive none from variables.get A and B in the task 1. Are you sure that you put task 1 as dependent of task? I think the problem is the task dependency.
Yeah. I forgot the dependency. You're right, Andros. So I just have to add proactive task 1, but add dependency. Yeah, this is why. Okay. Let's check again.
You don't need to delete the bottom codes also, or is it?
Since we did not execute it, it does not change anything for now. Yeah. No. Okay. And now we submit it again. And now it's okay. Thank you, Andrews. So what I wanted to show with this example is that in the beginning, when we executed the sequential version, like execute this, and this, you can see that the PID is the same. That explains that the same process is executing the whole notebook. But when we execute it in this manner, the PID are different. So the proactive tasks are executed in a separate processes. So this is why we have to do the variables propagation and the other part. So is it okay for everyone for this exercise?
Yes, thank you.
Welcome. Okay, so let's move to the second exercise. So now we will do the same, but using the Jupyter kernel. So you will see the difference. So you have to open the getting started proactive Jupyter kernel. From here, you can close this. You go back here, you open the getting started proactive Jupyter kernel. So as I said yesterday, we have the help pragma that can show you all the pragmas that we implemented that you can use. We will start by connecting to the server. We'll take it from here. No. Here. You will put your login and password. And we still have to work to get it protected. You will connect right away. It's done. And after, you can go forward to execute the other tasks. So here we draw the job and we submit it. So here we see the execution is done. And we can get the outputs here. So I explain a little bit the blocks. So here I create a task named T1 that contains this script in Python. Here I create a bash task. This is why I have to specify the bash language. And this is the script related. And here I create a third task, a Python task. By default, that depends from T1 and T2 with this script. So after, we just have to submit it with this pragma. So for the second exercise, which will be easier from my point of view, you will have to copy the same exercise, the PEAT exercise. Open a new block. And we have to try to do the same, but by using the Jupyter kernel. Is it okay for everyone? Okay. So here are the outlines if you want. Since it is 6 past noon, so we will do it together if you want. So we will start by adding a block to connect, like we did here. You have to switch the kernel to proactive before. So here we connect to the server. After, we will create a first task initialization here. So we will use the pragma task. We will call it init to create a Python task with this script. We will do some changes after. After, we will create the second task named calculation. Like this. So for the imports, we added a pragma called init. No, import, sorry. That allows you to import specified libraries to all tasks of a same script language. So since here we are coding in Python, we can import this library for all the tasks that are written in Python by using the import pragma. So after, what we did is that we have to mention the dependency between calculation and init. We can do it in this manner. We gave it a list of tasks names, and we have to export the variables a, b from this task to this one. So to do this, we just have to add parameters, do export. We give it a list a and b, and in the other side we do import equal, we give it a list a and b. Is it clear for everyone?
Yes.
Okay, so we will try to draw the job to see. Nice. Here we get the init and calculation tasks, and we can directly submit the job to the scheduler. So job 6341, 41, this one. So as you can see here, the workflow is created properly. So you can open it in the studio. I'm connected with other credentials. Oh, work. Okay, so this is it. You can see both tasks, init and calculation. And if you can see the task implementation of the init, you will find the code that has been added automatically with our pragma to export the variables and to import them from in the other side. So another main difference between the Python client and the Jupyter kernel is that a code which is written and executed as I don't know which one. Yes, this one. A code which was created as Python client, we cannot execute it very easily in a sequential way, because it's a code that creates a workflow of Proactive. But in the other side, if we use the Jupyter kernel, for sure we have less configuration and less control of the code, but we can switch very easily to Python 3 and still execute the same notebook in local. It's clear for everyone? Nice. So let me close this. So for the second exercise, what is needed is that we will try to change. We will use the easy one to go a little bit faster. We will have to change this machine learning basic script into a proactive workflow that does the same work. So here we have the libraries import. here we do the importing the database Boston, and we do some compression on it. Here we split the database Boston into two sets, one for testing and one for training. Here we train the model. We save it in a file, finalized model, and here we do the prediction. So I see the question of Miriam. Yes, for sure. Yeah. Yeah, exactly. When you open, it's a little bit tricky. So you have the corrections here. I put them for everybody. So when you open the Jupyter Lab instance, you will have them on the GitHub repository. So you can see here. Yeah, I managed it for you to not cheat in the exercise. This is why. So here you see the correction of the Python client PID exercise, the correction of Jupyter kernel PID exercise, and the Python client ML exercise and Jupyter kernel ML exercise. So here, as I said, in the training phase, we save the model into this file, and after in the prediction, we read the file and we do the prediction and print the result. So what we will do here is that I try to make it easy in the beginning, since we have 4 tasks. So we will start by creating the 4 tasks, but we can skip this part and move forward directly to create the workflow. So I will show you how to do it here. So basically, any user has to start with writing his code locally, maybe in his machine in Python, and execute the whole bunch of it straight away. We will try it this way. You can see the database. We will do the splitting here, training, the prediction, and we will print the result. So here you see the result of this exercise. So now a data scientist that wants to create a workflow from his notebook written in sequential, he will basically do this. I will open this part and let's start. So he will start by connecting. For sure, he will move his kernel to Proactive. He will start by connecting. After, he will use the import pragma here to say that to the kernel, import these libraries for all Python tasks. Saving Python imports, good. After, he will start by creating the first task. So we will call it import. I will go back to change some things after. So here we created the first task. After, we create the second task, name it split, that depends of the first task import. Nice, dependence added. Here he will do the same to create the train task that depends of the split. And finally, he will create the predict task that depends of the split and the train. Nice. So now we can verify our workflow. So it's a basic workflow of machine learning algorithm. And of course, we forgot to print the result. We can add it here in the predict task. Okay. So now what is missing? We can submit the workflow. I can show you. I can close this one. So here. Nice. So now when I submit the workflow, you can see that we will get some errors for sure for all tasks. Why? Because it depends from the machine. If we have all these libraries already set in, or there is a library that is missing, or there is something that is not properly configured for the data scientist algorithm. So as you see here, for example, import pandas as PD, import error, no model named pandas. So to countermeasure this, we have added a feature to add a fork environment for all tasks that are written in the same language. I forgot the name of the pragma, so I will cheat a little bit. It's job fork env. Yes, it's correct. Okay. And you can do it like this to get the usage of it. As you can see, we can specify the language, and we can put the name of the file, the path of the file that contains the fork environment script, and we can add a force on and off to force the fork environment for the old tasks that has been added or not. So here I will use the fork environment that I put it in the folder. I will use, for example, fork env, but it will crash. I will gain a little bit of time. If I use this fork environment, our script, our workflow will crash, because here we have a shared file which has to be accessed from this task and this one. So to go a little bit faster, I will use directly this fork environment. Path equal, but no, okay, shared dot py, and we will add force equal on.
Khalil?
Yeah?
Just make sure to
change the path?
Yes.
Yes, I will do it. Thank you, Andrews. So since we will save this file into the shared space, we have to give the absolute path for the file. So /shared/finalized model. So is it clear for everyone? Okay, let's try. And submit. As you can see, oh, no, split, maybe. I will do it again. Maybe there is some task that has not been changed. Ah, no, oh, I forgot another thing. So I forgot to export the different variables that are needed in the other sections. So as you can see here, we have the xtest, the xtrain JSON that will be used in the other parts. So let us do it. Export. So for this one, we need the data frame JSON that is needed here. We will export it. Data frame JSON. Okay. For this one, we will import data frame JSON and we'll export the xtrain JSON and xtest JSON. These. Execute it. Execute. Here we need the xtrain JSON. And the data frame, not.
It's okay.
Yeah, but we have to export the file name. And the columns. I need it in the prediction. I think it's okay. And for the prediction, we have to import the xtest JSON. And the file name. And what else? And columns. Okay, I think we are good like this. So let's check out that everything has been executed properly. Nice, nice, nice. Good. Good. Prediction. Oh, we can draw the job and try to execute it. Now it's okay. For the split task, it's okay. And everything works fine. You can see here. So we can get the results and we can do anything from this workflow. I explain it another time. Even if we will change to Python 3, all the notebook can be executed without changing many things, just by maybe modifying this path because we don't have a folder shared here. And everything works fine. So anybody can train his model, can write his code, verify that everything is good, and just with switching from Python 3 to Proactive, he can execute his code by creating a workflow and executing in the scheduler in parallel. So I don't know if there is any questions. It's good for me. So it's okay. As I told you, all these scripts are available for anyone in the GitHub repository, and you can test it. You can play with it when you launch a Jupyter Lab instance, or by creating your own in your machine. Same for the proactive. Jupyter Kernel and Python SDK. You can install it in your machine and connect to the server directly and play with it. So,
Khalil, is it available on the HP platform that we are using right now?
What exactly?
You say all the scripts are available. They are all on the platform?
Yes, exactly. They are all in the platform. I updated the Docker image with the new GitHub repository. So these corrections and these exercises are available.
So is it clear for everybody on how to access those?
Where in the GitHub repository it is? Can you paste that in URL or something? Or
yeah,
Git?
sure. Okay, I will give it to you. Oh, just 1 minute. It's this one. Thank you for that.
Andrew, one question. I tried to run my TensorFlow and I couldn't get my workbook working. Later, if you can just have a review what I missed. It shows me finished. I don't see in my service job in cloud automation my flow. Jupyter is fine, but I didn't see my
MongoDB. Yes, I don't see your PCA. Maybe.
Yeah, I don't know where my. I tried to select it and run, but I think I missed something or what.
But maybe if you gave the same for Tensor.
Yes. In fact, everyone used the same Tensorboard ID, so there is only one.
Only one, exactly. Yeah.
No, I couldn't get it. What do you mean?
In fact, as we use the same instance ID, so there is only one single Tensorboard instance in the server.
Okay, so I cannot run it only one by one as a one kind of a thing, right?
Yes, you can run your own Tensorboard, but you need to change the Tensorboard server name.
It's like when we did to the Jupyter Lab, if you use the same instance name and the same endpoint, you will use the same PCA that another user. So here, this is what you did, all of you. You
How did you go to that screen? How did you go to that screen? The one which you showed? Click the UI.
Yeah.
Oh, the now the one, yeah, the not that one, not that one. The one which you showed now, that in the TensorFlow, how do I go that GUI?
Yes, you can, Khalil, you can show the service activation instead of Jupyter, show the Tensorboard.
Okay.
Yes.
Like this. You see here.
Okay.
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 But maybe
so I need to select the same name, instance name, and Tensorboard UI.
Yeah,
exactly.
You should specify instance name on the endpoint ID with different names. You can put like you did for Jupyter Lab.
Oh, Jupyter. Okay. 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 So then it will start another one. Okay. Got it. Thank you.
So it's all for us.